Somewhere, not far from Earth, a star enters its death throes and explodes in a violent supernova, leaving in its wake the strangest phenomenon in the cosmos, a black hole. Our galaxy may be infested with millions of them. But now, there's evidence of something even more ominous. Black holes of unfathomable size and power.
That's a big galaxy, and right down at the center, you can't see it, a black hole that's got a mass that approaches 1 billion suns.
Astronomers are now studying them in unprecedented detail and finding they are bigger, stronger, and more destructive than anyone imagined. We'd like to think black holes are far, far away. But what if there's one on our cosmic doorstep? A team from Europe and another from the United States are in a high-tech race to be the first to see into the very heart of the galaxy. Now, an extraordinary new experiment is giving astronomers a first-ever glimpse inside a black hole to see what's in the lair of the monster of the Milky Way. A new era in astronomy has begun. High-tech instruments in space are now revealing a universe rocked by violent events.
JPL Chandrosi.
In the distant galaxies, astronomers have witnessed space and time shattered by eruptions so vast they boggle the mind.
To put this on sort of an Earth scale, it's equivalent to about 1 trillion atomic explosions.
But what could produce such awesome power? Whatever it is, it lives at the center of our own Milky Way. Scientists now believe it is the largest and most powerful object in the universe, and yet it emits no light. It is called a black hole. First suggested by Albert Einstein's equations, a black hole is space and time twisted into a furious knot. But the great scientist believed it could never exist in nature.
Albert never really liked the idea of black holes himself. He thought they were anathema. This was something that nature should avoid. It's the places where space and time became infinitely twisted up. He thought, no, nature shouldn't allow that.
Black holes are certainly odd beasts in the universe. They were thought to be peculiar, so peculiar as to perhaps not even really exist in the real world. Simply because your equations show that they can exist doesn't require that the real universe has them.
That there is something strange and powerful lurking in the center of our galaxy first became clear 75 years ago. Early radio telescopes recorded a hiss like the sound of steam. As a young astronomer, Eric Becklin was determined to get to the bottom of this mysterious energy source. First, he had to find it.
There was a radio source called Sagittarius A, a very strong radio source, but there was even debate whether that was really the center or not.
Astronomers knew that the centers of other galaxies are tightly packed with stars, but when they tried to see into the center of our galaxy, those stars were obscured behind a thick veil of dust.
There is so much dust between us and the galactic center, it is completely opaque. You do not see the stars in the galactic center. The most powerful telescopes cannot see it.
Becklin knew that some kinds of light, invisible to our eyes, can make it through the dust. Infrared, for example, travels in slightly longer wavelengths.
Infrared radiation gets through the dust because its wavelengths are longer and the dust just kind of rides on the infrared wave.
In the 1960s, Becklin bought an infrared detector from a military contractor and attached it to the end of a telescope.
It was in August of 1966. It was a beautiful night. As we were looking with the infrared detector, we were seeing more and more stars, and the signal increased, and each star gives you more signal, and we were building up. As we were getting closer to the center, more and more stars. We were actually seeing through the dust for the first time, and then came to a peak, and then back down again. And I knew immediately that that was the center of our Milky Way, and that I was the first person to actually see the stars in the very core of our galaxy.
Eric Becklin had discovered the very heart of the Milky Way, the exact location of the mysterious energy source. But its staggering power meant that this was no ordinary star. Scientists believed the only one thing that could explain the mystery was the very idea that Einstein had rejected, an object that defies explanation.
What's a black hole? It's this monstrous, mysterious thing.
It's a point of infinite density. We don't know how to wrap our brains around that.
It's a region where space and time have closed in on itself.
A black hole is a region of space where the pull of gravity is so immense that not even light can escape it.
You reach the point where light cannot even come out. And if light can't come out, you're not coming out. And if light plus you are not coming out, it's a black hole. There's no other phrase we can possibly use to describe it.
Welcome to the strange world of extreme physics, where space and time literally cascade into the abyss.
Space itself is falling inside the black hole. It's rather like a river falling over a waterfall, except it's space itself that's falling over the cliff. It's rather like a kayaker trying to make their way upstream on a river that's going too fast. They get dragged down to the center of the black hole.
Gravity becomes a riptide. The closer you get, the stronger the current. Eventually, you reach the event horizon, the point of no return.
Matter goes inside the surface of the black hole, shrinks down to the very center, where it gets destroyed in a region of infinite warp space and time, and it's gone.
The gravity at your feet, if they're close to the black hole, is a little bit stronger than the gravity at your head, and you feel that as something that is tearing you apart.
The tidal forces unrelentingly getting stronger as they exceed the molecular forces that bind your flesh. And so you end up moving through space-time like toothpaste through a tube.
And ultimately, you will pull your atoms apart. You will be, as we say.
As strange as they are, black holes are a product of the familiar universe of stars and gravity. They have their genesis in a type of enormous star called a red supergiant. It is 10 times heavier than our sun, yet it will burn itself out in a fraction of the sun's lifetime. Deep inside, the crush of gravity sends temperatures roaring above 1 billion degrees. Helium and carbon fuse into heavier elements: oxygen, silicon, sulfur. Then, the star implodes under its own immense gravity, sending a shockwave roaring out. The star digs itself deeper into space travel, and now goes supernova in a violent explosion. What's left is a dense core of subatomic particles, a neutron star, only about 16 kilometers across.
It's so dense that a teaspoonful of neutron star matter would weigh about 1 billion tons. Eventually, the gravitational pressure will be so large that the neutrons themselves will be crushed, and there'll be nothing left to stop the collapse.
A black hole is born. It's 1 million times the mass of the Earth, but compressed so tightly, it literally exits the known universe.
Now, the effect of that mass is still in our universe. The mass is still here in that it's causing this fold in space that goes all the way down. It's become a hole. The best way to look at it is, if you stick your finger down in there, you ain't getting it back.
We know exactly what effect a black hole is going to have on its environment, on the stars in its vicinity, on the gas that wanders a little too close. So, will we ever see a black hole? No. But that's not what's important here. What's important here is we can see its paw print.
In search of a black hole's paw print, Eric Becklin is on a lifelong quest to probe the center of our galaxy. The Milky Way is a giant spiraling disk of over 100 billion stars. Our sun is about halfway out, in the peaceful suburbs. Becklin is headed to the galaxy's most exciting and most violent zones. But to make the final leg of the journey, he would need help. So he turned to a rising star in astronomy. Andrea Getz believes that the key to finding a black hole at the center of our galaxy lies in tracking the stars that buzz around it.
For about 3 decades or so, there has been this question of whether or not our galaxy harbors a supermassive black hole at its center. And the key to answering this most definitively is to watch stars at the center of the galaxy orbiting.
Getz's team set up at the newly built Keck telescope on the summit of Hawaii's Mauna Kea volcano, the largest telescope ever built.
Our view to the center of the galaxy is absolutely superb. Our ability to position stars at the center of the galaxy is like somebody in Los Angeles seeing somebody in New York be able to move their finger like this, okay, just 2 centimeters. That's the precision with which we can measure something that is 26,000 light years away from us. Madeline, we're ready to go?
The conclusive experiment to be done that really demonstrated that it was a black hole was to follow the orbits of individual stars very, very accurately and with the highest precision possible.
But the stars in the center of the galaxy were not the only thing Getz and Becklin had to keep track of. Another group, working in the mountains of Chile, was hot on the same trail, led by Reinhard Genzel from Germany.
This guy here. Yeah. It's a little too dense to be just a random collection. We suspect that in the galactic center there may be hiding very massive black holes. To really be sure that they are black holes, we have to go in there as close as we can, so we can make measurements really good enough now that we can say it must be a black hole.
Both teams wanted to be the first to prove that our galaxy harbors a supermassive black hole, but Genzel and his team had a 3-year head start. The amazing precision of Keck is the ace in the hole for Getz and her team. Mark Morris is a veteran of the Galactic Center search.
The German group had already started to make headway on the Galactic Center even while we were deciding to pursue this. So we knew that in a head-to-head competition, that as long as they were using the small 2.2-meter telescope that they were using compared to our 10-meter telescope, that we would blow them away.
Bright speck on the top of this inset. That's the star which really has given us the essential clue for the black hole.
It was certainly high excitement, but on the other hand, we would have to compile like at least 5 years of data before we could see the stars move.
But what kind of cosmic monster was pulling the stars along?
This is our roadmap, and that's the center of our galaxy. There's a large cluster of stars that are orbiting the center of our galaxy. Basically, the way this experiment works is you take an image, you see where all the stars are, and then you come back sometime later and you take another image and you look to see if they've moved. So the second time we took an image, we knew